All right. Well, we're about 4 minutes in, so I'll go ahead and get started. Thanks everyone for joining us today, and welcome to BRIC's Pre-Apprenticeship Speaker Series, where we aim to give you an inside look at the various careers across entertainment, media, and tech with help from the industry pros themselves. My name is Sarah. I'm BRIC's Director of Communications and your moderator for this series. And today we're joined by our very special guest, Sally Slade here, who is the principal developer of avatar interactions at Genies in Los Angeles. She's a veteran immersive developer and has shipped virtual production, VTubing, AR, and VR utilities and games to nearly every XR platform available since 2016. Prior to working in games, she also worked in film as a VFX technical director. So she's got a really cool journey. In this session, Sally will introduce you to the creation of game-ready 3D avatars capable of real-time animation, speech, and user interaction. But before we get started, I do want to remind everyone that we always do a live Q&A during the last 15 minutes of the session. So make sure to use the Q&A button at the bottom of your screen to submit any questions you have for Sally along the way. And with that, Sally, I'm going to turn it over to you.
Okay. Thanks so much, Sarah. All right. Hey guys, sorry for making you stare at my LinkedIn. I don't really have a slide for myself at this time. But what's up? So the goal of the class today is to expose you to a bunch of different technologies and career paths that mesh together during the creation of smart avatars. And we will also be creating a smart avatar. Yeah. A smart avatar is a digital character that can talk, think, reason, and move in a manner that is lifelike or otherwise suits their character design. So, since this is like career centric, I'm going to tell you briefly about my career shortly. I started in visual effects as an intern on the Golden Compass and Speed Racer. At that time, I had a bachelor's degree in computer science, and I was working for a company called Digital Domain. I was helping to process data that was collected on set, and eventually I moved on to lead a technology division at another company, Scanline VFX, supporting their compositing team. Compositing is a team that layers the rendered effects themselves into actual footage. So that's a career right there. After working on compositing is after working on about 30 films as a technical director, I pivoted to virtual reality. There, I worked at a company called Magnopus. Exciting stuff was happening, and I wanted to be part of it. That was the first time I realized how powerful it could be to interact with avatars in an immersive space. Looking into like a virtual mirror and seeing your avatar look back at you is pretty cool. And hanging out with your friends in a virtual like venue is pretty cool too, especially when they live far away or like there's a global pandemic. Yeah, so TLDR, I've been working in the entertainment space for about 18 years, doing films, VR, and even an anime project from Tokyo. So yeah, now, new slide. Yeah, now I work for Genies. We are in the avatar technology space. So our founding vision was to create a visual identity layer for the internet, meaning like in the 90s, everyone had a screen name. It was how you were known online. And like our idea was that the internet would continue to evolve and people might become known by more than just like their username, which is like text on a screen. We thought they'd want like an entire avatar identity. So if you're into like Bitmoji fashion or Roblox or VTubers, then like you're familiar with this idea of an avatar identity and you know what I'm talking about. Anyway, technology has evolved a lot since then, and we now have, in addition to like a visual avatar layer, we've got this idea of like an intelligence layer that we can work with. So if you've talked to like ChatGPT or met the talking Darth Vader in Fortnite or like used the My AI feature on Snapchat to like do your homework, then you are working with that same intelligence layer. So that's powered by what's called an LLM or a large language model. And if you're following the news, you'll know there's like a lot going on in this space right now. So if you do have a particular stance about AI, please note that this lecture will focus on like community developed, free, open source solutions that are local to your machine, meaning like they can run offline, you're not touching any kind of data center, the amount of energy you're consuming is consistent with like daily use of your own machine. And we won't be working with generative AI either. So like should be chill for you. Anyway, so what we are making today is an interactive smart avatar you can talk to using your voice and a microphone, and it will reply to you with its own voice, animation, and lip sync. So by the end of the class, you should have a solid foundation for building your own custom avatar or like chat companion. And I'll just like show you what that might look like really quick so that you can kind of visualize what we're building as we go. Um, okay. So here's like a little guy. We'll just do a quick test. This is like the final sort of product for today's workshop. So I'm just going to hit play on this. It's going to crunch its little numbers. There we go. Okay. Yeah, wave high. So this is a smart avatar. He's like chilling. I'm going to talk to him by holding down the spacebar real quick. Hey, bud, how are you doing? And then it's going to take my text and it's going to think about it. Sorry, my machine, little old. And then he will reply. Um,
Yas, I am Loki good. Just chillin' with me tea and biscuits.
so that is your smart avatar sample. He generated his original response based on a personality we prompted. Um, so that's what we're going to be making. So let's get into it. So at the company I'm at, Genies, we've got some really cool philosophies. One thing I really like is the way we break stuff down into these three categories of looks, brain, and behavior. Um, Play is another one, but we're not going to get to that. So looks refers to the avatar's appearance, not just like their hairstyle or color palette and clothing, but also how the avatar is rendered. Like, does it look like an anime? Does it look like a film noir? Does it look like Pixar? Does it look photo real? That is how it is modeled and how it is lit. So that's two career alert right there, modeling and lighting. Modeling refers to the creation of the 3D character mesh itself. So think of like sculpting an action figure, but instead of using clay, you are sculpting vertices and geometry in a software like Blender or Maya. The other one I mentioned is called lighting. Lighting's like a highly technical profession where the artist understands how these light parameters interact with different surfaces. Excuse me, and define like how that light would bounce around or illuminate things according to style. So like here's something with no lighting, here's something with lighting, just so you kind of get the idea of what we mean by that. Anyway, yeah, career alert. In this lesson, we're going to focus on a cartoon or anime style lighting because it's very popular right now, which means there's a lot of resources. So we are going to use this avatar builder called Vroid to kind of create the base of our avatar, to create the model and the lighting and the looks of it. So avatar makers themselves, like the ability to kind of assign hair and eyes and clothing, it's pretty expensive and time consuming to create that software. So the fact that Vroid is out here giving it away and letting you export their avatars for free is like pretty incredible and pretty useful. And that is why we're gonna use them today. So for the inspiration for the avatar we want to create, I'll just share with you some nerdy stuff. In Japan, there is this mascot called Unity-chan. She is a cute girl mascot that anyone can use to prototype a video game. And it's a very popular way to get started using Unity, which is a software we'll get into. She like comes with it for free and you can make whatever you want with her. It's great, but there is no boy equivalent. So I thought like, oh, I need to make like a boy one. What if people want to prototype with a boy? Like, let's go. So we've got Unity-chan here. This will be Unity-kun. Chan is like Ms. Unity, Kun is like Mr. Unity kind of vibes in Japanese, whatever. Okay, so let's begin. I will show you Vroid, our little avatar editing software. Just gonna launch it here. It's free on Steam. Okay, so we are going to create a new masculine model, and it's gonna load the base for that now. Okay, so here's like a 3D, like sort of base avatar they've got for you. There's like all kinds of different options. You can pick like whatever eye shapes you want, like any kind of adjustment that is suitable to your character design. Our guy's pretty basic, so I'm going to go with like a default here. Hairstyles, there's so many. You can like modularly adjust them if you want like the back to have like a mullet and then to have like pigtails or whatever. There's just so many options here. I'm gonna pick this like kind of longer one to like match our design. I'm gonna make him like blonde. And again, this is not quite what whoops, where'd my, it's not like, well, we'll get there. We're gonna get there. Um, for an outfit, he's wearing like a sort of butler thing. So I'm gonna pick this tuxedo, I believe. Yes. So getting close and like all of these parameters, there's so many to like just kind of define, like really noodle on what you want this shape to look like. Um, and you can get pretty close. And let's see, he needs some shoes. Oh, he's got shoes. Okay, this was like a whole pre-made outfit. That makes the demo pretty quick, but take my word for it. There's a lot of things in here you can do to like build, whatever kind of look you want for your guy. Like maybe I'll switch to this one. I don't know, but whatever. It's very flexible. It's very nice. It even lets you edit these textures in here. So if I were to go to the Edit Texture button, um, here on the left, we have our 3D model, and on the right, these are the textures that make him up. So if I were to draw like on here, you can see on the texture like where the illustration is happening. So like we can see this part of the texture map goes with his sleeve, and you can get like pretty creative if you want to make a certain pattern, whatever. You get your stylus out, you draw something meaningful, not a bunch of scribbles, and you can export that and then like save it. But modifying textures is like a great way to like really dial something in. In fact, I will show you a bit more about that in just a moment. So this is pretty close to what we want, if you use your imagination. So I will just show you that here we can test how the character rig is looking with some pre-made poses and animations. So we can click any of these presets and it will move, and we can be like, yes, the coat tails are behaving as I would expect them to. He's stretching, he's moving, it's good. Nothing catastrophic is going on here. So from here, you would export the model, but that can take a bit of time to save. So what I'm going to do instead is just show you the finished product of this export. Okay, which is here. So, oh, I guess I went with this suit ultimately when I exported the other day. So you can see here, this is kind of the full result from that avatar editing software. And what you can do there is open like a Photoshop type program, or I'm using this one called Photopea, which is free, photopea.com. And you can edit, like here's that same shirt texture. I tinted it blue. For his pants, I put the stripes on them using these Photoshop type programs. And then ultimately, I modified each individual texture until it matched my character design here. And that is how we ended up with this guy. So yeah, made a whole avatar for free. Didn't have to learn to model or rig or light or anything. Super nice. We love a good avatar editor. So let's see. Let me drink some water. My friend told me to talk slower. Okay. So looking at our Mr. Unity guy in here, this whole software that you're looking at, all these gray panels, this is called Unity. This is a game engine. Game engines are what allow us to connect these 3D models like this one to pieces of code, to like code we're writing in a programming language. So if I were to click him, you'd see all these little modules that are connected. Each one of these is a script that we've written in the C# programming language. So yeah, for example, you could have a script that makes the character blink once every 5 seconds. You could have a character, or you could have a script that makes the character wave hello to you. You saw that when I hit play earlier, the character would like wave and then he would just like stand around. So that was like a script I have that's like, hey, you should wave when the app launches. So yeah, these scripts are written in C#. Different game engines use different programming languages. You may have heard of Unreal Engine, which is used to create Fortnite, for example. That engine uses C++. But yeah, working in Unity or Unreal, by the way, that is like also a whole career. That is essentially called being a game developer. I was a Unity developer for the last 10 years. We were using the Unity game engine to make games, to make VR stuff, to make experiences, to make apps, utilities. Like it's just very flexible. You don't have to make a literal video game. You don't have to make a smart avatar. You can make pretty much anything you can imagine that is, yeah, anything. Like, game engines are magical. Yeah, so back to smart avatars. If you don't like the look of Unity-kun, you're like sick of anime, there is a whole wide internet out there. You can buy or create the avatar of your dreams, whether you want like a photo real one that could go right into a film or like a highly stylized one that's like, I don't know, like Looney Tunes looking. You can even make avatars out of 2D illustrations or drawings. Like this is a 3D avatar, you can make a 2D one. There are no rules. Yeah, so that is our looks. You remember we have looks, brain, and behavior. That concludes looks. We have defined what the avatar looks like. Let's talk about its brain. Okay, brain refers to the ability to communicate, taking the user input and creating a chatbot output. We are going to use GPT for all. Let me show you what that is. GPT for all. This is a localized LLM that anyone can install to their machine. LLM stands for Large Language Model. It is the byproduct of a machine learning process in which data models were trained on how to provide compelling chat responses to people. So yeah, machine learning, also called ML, this is like a whole career path as well, like a whole umbrella where you can have multiple jobs like doing machine learning type stuff. But in this career, developers focus on taking specific input and then creating unexpected output. They do this by submitting hundreds or thousands or like even millions of examples of sample input, and then they will like generate like this is what the output should be. If I give you A, I want B every time, and they'll just show them over and over, show the model like different variations of what this could be. And then when the work is finished, the model can create its own output without having to rely on further samples. Like it can walk on its own now, type of thing. So yeah, this is like how image generation works when you give the input of like rainbow and dolphin, and then it gives you like a rainbow and a dolphin like JPEG. That's what it's doing. Likewise, this is how chatbots work. So you can give the input of like, hi, how are you? And you get the output of like, I'm fine, thanks. So yeah, GPT for all, it's not quite as mature as like ChatGPT, for example, but it is open source and it's free. It's not trying to take over the world. So any shortcoming that GPT for all might have with regard to like the quality of the output, just consider it cute. It's very punk. We love using these off-brand products. Once you install this application on your machine, which you'll need to do if you want your avatar to have a brain, then you can start talking to it. So let me show you what that would look like. So here it is when you've installed, you hit start chatting. You can have a little conversation in here, um, or it could like freeze and you would be devastated because you're doing a live demo. That's also fine. But yeah, you have options to turn on an local API server, which sounds very technical. What it means is that this chat interface, like this very friendly looking, normal looking chat, it runs in a terminal as well. Like, I don't know if you've ever seen a hacker, but this is what they do. They use terminals. So we can have this long command here that's like speaking directly to the locally hosted LLM model. It's talking to GPT for all, and it's sending the message of hello from an API call. So if I were to send this, then it replied very quickly, yes, what's good? I'm here, lol. Um, I instructed my GPT to talk casually, which is why it does not sound so much like a robot. I don't know, whatever. Okay, so that's kind of what's going on with our brain, our avatar's brain. So let's get back into the game engine here. And I'm going to pull up a different scene for us to look at. This is a little scene that will test the brain out. So if we want to talk to GPT for all, our little LLM, using, without having to deal with typing, we want like a voice-to-voice solution. So that sounds hardcore, but using like the open source ecosystem, there are tons of modules out there that we can borrow. So we are going to be capturing the user input with Unity's own thing called the inference engine. So let me just show you what that means. We're going to be doing some speech to text. And then Unity itself uses open source models as well to like kind of get the expected input, which is voice, and then deliver the expected output, which is text. So if I were to, let's see, hold down spacebar, testing input, what I spoke, and there you can see that it transcribed it. So that's pretty cool. We are also using some text to speech. So if I were to speak this text, it will use another module from the internet, just another open source thing called Kokoro, which is Japanese for heart, because it gives you heart. Okay, so if we speak this,
Testing input.
brilliant. It used the voice I instructed it to, and it fabricated like out of thin air, like, an audio file, which is like amazing. And then just a little bit on how this game engine is working here. Like, let's take a look real quick at these buttons. So this like speak test button, we can check out the inspector here. Here's like the button script. This is a script that Unity Game Engine itself ships with, and then you can like fill out all the little things like what color do you want the button to be? Like, well, maybe not that. But yeah, I have connected my own script here. So whenever a user clicks the button on click, it is to find this script and run this function called speak debug text. The script it's trying to find is this one called round trip test. So let me just show you. As I mentioned, each one of these is a little script that someone has written, whether it's Unity wrote it, whether a third party wrote it, or whether I, the user, wrote it, it's there. So let's take a look at this one. And speak debug text was the name of that function. Let me see if I can make this bigger. This was the function that was called by that button. And you can see it's just calling that module Kokoro and saying, hey, speak the text and use the voice I have assigned. So like it's all in there. Like Unity doesn't have to make stuff up. Like we're telling it exactly what we want it to do. We're giving it very precise instructions. And then you might be wondering like, okay, well, what is the text that it's speaking? Like it's all just hooked up in this interface here. So if we were to look at this round trip text component, the text it wants to speak here, this debug text, if we were to click that, it's got the field right here. Testing input is the thing we had it speak. So it's all connected. We'll get more into scripting in a bit. That was just something to get your feet wet. Um, but yeah, we can also have an LLM reply. Oh, finally it made it red. Oh, I see. Okay, whatever. So I made this LLM test reply button. What this is going to do is it's going to take anything that's in this field, like, hi, buddy, what's up? And it's going to send it to that LLM brain, and then it will reply with a text reply, as we've seen. It's in these like sort of chats, as we're used to seeing with ChatGPT or whatever. It will give a text reply, and then it will speak the reply using this Kokoro voice synthesis. So let's give that a try.
Nothing much, just chillin'. How about you?
Like, this is pretty cool. Like, the brain came up with this original response. This Kokoro module just like created a voice clip to go with that. Like, we're loving this. We're feeling powerful. We have a brain, we have a voice. We are ready to put it into our avatar. So we've got the looks, we've got the brain. Now we're going to get into the behavior. So let me get back to our main script here. There we go. I hope you can't hear my deskmate typing up a storm. Okay. Um, so let's get into behavior. Behavior is like how the avatar animates, how it emotes, how it reacts, how it behaves. So this could be in response to user input, or like if it's just vibing on its own, like how's it going to act? I think this is the most interesting thing that is like happening in the smart avatar field right now, because there is no fixed solution. There's no like set of guidelines. It's like, well, how do you make a great smart avatar behave? Because we don't have an answer yet. Like the smart avatars we see in the market right now, like they have like predictable emotions. They're always kind of swaying in the same way. You know that they're gonna just do whatever gesture right before they do it. Like it's still evolving. So this is an exciting place to operate. Um, And that applies to robots too. Like I know we've seen those like biped robots that walk around, but they're like a bit uncanny. Like when something is so very real, but it's not quite real, so it feels a little creepy. Um, that's a problem that we don't actually have today, because on the other end of Uncanny Valley, is just like the chopped zone. So that's where we're gonna live, where something is so unpolished that it's like endearingly bad, and you get excited and you get inspired, like thinking about how you could improve on it. That's what we're hoping to reach today. So yeah, hopefully we can give you a foundation where you can implement your own looks and brain and behavior and start developing the avatar of your dreams on top of this like very basic entry point. So yeah, let's get into that. Let's attach the We've got the looks, we've got the brain. Let's attach the behavior. And let me take a hydration break. Okay, there are three types of animation that I would like us to explore to power this behavior. There's lip sync, which, as you may know, is like when your mouth moves to shape around the words that you are speaking as you are speaking it. That is lip sync. We've got animation clips. This is like when you've got like a little animation that you've animated yourself, some keyframes, something like you have an animation that you downloaded from the internet and you want the avatar to perform that animation. That's an animation clip. And then there's procedural animation. This is like when you code something, like you're kind of coding like uh, sorry, I just realized I freestyled all that and I'd written all these really clever notes about it. So now I'm lost in my own sauce. Okay. But yeah, let's let's get to some procedural eyeball movement. I will show you how we can use code to drive this. So first thing I'm going to do is explore Unity Coon's rig here. So if we look at his face, um, I'm going to explore. This is a hierarchy of every bone in his body. So this is the eye bone. And we use the word bone synonymous with the word joint. It just refers to like a little unit of skeleton that we can manipulate to change something. So you can see as I rotate this joint that his eyeball is moving. And we can do that for like any joint in the body. So we can create a lot of compelling animation by just driving these values with code. So let me show you what that means. If I were to hit play here, it's got to connect all these scripts together and yeah, calculate what that will look like. Okay, so here's our guy. He waves every time you hit play. That is a behavior we added. So you can see his eyes are looking at random locations. They're actually looking at this little sphere here. I have written code to move this ball all around, and then he'll like look at it, and he'll do that with both his eyeballs and his head. So the more this thing moves, the more he's going to turn to look at it. And the idea is that like, okay, it gives him like a sort of vibe. Like if I'm ignoring him, he's going to like look around. He's got his own thought process. He's got his own thing going on. So that is procedural animation. Let's take a look at that code. So if we were to select this avatar here, and then look at all the scripts that are powering him, there is one called idle look around. It's for looking around when you're idle. You can see it has a reference to his head bone because that is going to be rotating. The script is going to rotate this. We've got his eye joints. It's all kind of getting pulled into this script component. So if we were to then look at this code, um, I will walk you through it. And by the way, this is like a very simple code that was written by Claude and AI. And then I reviewed it to make sure that it did the thing I want, which is like a very exciting new frontier, a new way to learn how to use code. It's a new way to prototype quickly. I recommend giving it a try. Let me just detour real quick and show you what that would look like. Um, if you were to go to Claude website, you can say like, hey, can you write me a Unity script that moves the eyeballs of my character naturally? please keep it short. Then it will create this entire script that will just theoretically work. Um, This is skill is for front end design. Anyway, so while that is crunching on that, I will just walk you through a little bit more of this. But the thing I wanted to show you in here was this is sort of the heart of it. Pick a new gaze target. Like where is your eyeball gaze going to focus on that little sphere we were seeing? It's going to have these numbers that define that. Like it's going to hold on to that target for like a certain amount of time, which will be like a random range between like the least amount of time we want it to hold and the most amount of time we want it to hold. Pick somewhere nice in the middle that's random so that it looks like it's looking all over the place, not just the same thing over and over. We've got an X value and a Y value that will drive like a rotation. And that's also just a random range. And then eventually we like set this position of like where in the world it's going to be. And occasionally, like anytime, maybe 25% of the time, we'd like it to look directly into the camera so that it doesn't seem like a total space cadet. So like this is all just very specific instruction to the machine. Oh, here's what, Claude made for us. Like, I'm pretty sure if I pasted this in, it would give us a desired behavior or at least a really great starting point. So like that is a tool you can use as well. Yeah, but that informs our looking around randomness script. Yeah, so that is your full-on procedural animation definition, demo, what it is. So let's get into the next type of animation. That would be using animation clips. So there's a lot of resources for this as well. Here's one of my favorites. This is a website called Mixamo. It's owned by Adobe. It's at mixamo.com. And it just has like hundreds of animation clips that these like humanoid characters are doing. So we can download any of these and they will just like work for our avatar because Unity has figured this all out and made a very nice pipeline for it. And you just drop it in and it's good to go. So we could like look through these and find one that we'd like our avatar to do. Or we can realize like, oh no, they don't have the exact like clapping gesture that I want. Like, whatever shall I do? Well, you've got some options. You could learn to animate. That is a full-on job, animator. Or you could use motion capture, which is another field that is like emerging. So motion capture, this is a company called Move.ai, and they specialize in real-time motion capture. Like this guy is on set, he's like walking around and we're capturing his movements here. Another thing this company does is it takes a video clip and then turns it into motion. So I'll show you like a quick demo of that as well. Let's see. We have this super cringe video of myself clapping. So very distinct clap motion. I put that into Move AI, and then I was able to get this animation out of it. And yeah, I was able to do that for the clapping, for what's called an idle pose, which this is just how our Unity character stands around based on the motion from my own recordings. I also have a friendly one. This is like, oh, you kind of animation, and we'll hook that up to our character as well. And then lastly, this wave animation, which is currently hooked up to the character, which he performs this wave anytime you launch his application. So yeah, those are what's called animation clips, and that's one of these three ways we can animate: procedural, animation clip, and then, oh gosh, what was the other one? Oh yeah, lip sync. That was the other thing I wanted to show you guys. So yeah, that's that. Okay, so animation clips though, I'm not quite done showing you stuff with regards to that. I wanted to get back into Unity's skeleton here. So if we were to rotate like his arm joint, for example, then like, this is the exact kind of motion that is stored in these animation clips, and it's just applied to this character, when we hit play. So it can bend any joint, and that's how we kind of like bring life to it. I'll also show you what's called an animation controller. So this is like a map using those clips I just showed you of how this character moves. So you can see on entry, he will wave, and then he will default to his idle state and just hang out in idle and like loop and blend his own little idle, unless an event happens. At any time, at any state, we could have a trigger, which in this case is called point, or a trigger for this animation, which is called clap. So I've hooked these up to behave in a certain way with our character, and I'll show you that as well. So we've got this little script on here called keyword animator. And what it does is it attaches itself to the LLM, just like via these references in here. See, LLM is pointing to the LLM node. Speech to text is pointing to our little speech to text thing that is helping us get a transcription of what the user is saying. And then we're pointing to the animator as well, like the little component that lives on this avatar that moves all those joints and rotates them in accordance with whatever animation clip is going in there. So if we look at this code, so this is a pretty small, like nice little script. We've got the references I just showed you. On start, which is run by Unity, anytime the application starts, it will run this stuff. What we're saying here is that for the LLM, for the brain, anytime we receive a response, we want to handle that response. And then likewise, anytime we receive a speech to text transcription, like anytime I speak into the microphone and it gives me text back and the audio is transcribed, we want to handle that too. So let's look at these little handle functions. For handling transcribed, like anytime I speak and it gives me text back, if that transcript has in lowercase the word applause, like if the word applause is contained by that transcript, then we want the animation to trigger the clap clip, meaning that like anytime I tell the avatar, like, give yourself a round of applause, he will like clap because of this little line of code. So that's like one behavior that he has. Another behavior that he has is anytime the brain returns a response, if that response contains the word mate, because he's like a British dude, then it will trigger a response where he points, in a friendly manner at the screen. So he'll be like, oh, mate, kind of thing. So that's like another behavior that we have. And like I didn't mention this, but like if we look at the LLM component on this character here, the brain component, and this is like a LLM is like a giant script that we got from the open source community. So I didn't write this. I just am dialing in all these little extra features. I'm telling it where my GPT for all script is located. Like I'm telling it the information we sent like this. And then I'm telling it this creative bit here. I'm saying like, you are Unity-kun, you're Mr. Unity. You speak with British slang, mate. You love making tea and watching rugby at the pub. Like you're kind of just prompting this like sort of character vibe into him. You're giving him like a little soul, so that will inform the way he speaks to you when you're chatting with him. So that's where that all comes from. So depending on what I'm saying into the microphone, he might clap. Depending on what he's saying to me, he might like point at the screen in a friendly way. Yeah, so we can just like put all that together and see what we get. So yeah, let's see. Let's give it a try. I'd like to demonstrate for you now that you kind of have an idea. We can like point out all these things that are happening. So I'm going to hit play. And it's compiling all these pieces and putting it together. So he's loading up his state. He's waving because that's the first thing he's meant to do based on that animation controller that we looked at. And now he's like looking all around. He's chilling because of that procedural animation that we introduced. And now we can test the this is the same thing we did before, but now you know what you're looking at a bit more. So if I am going to say the word applause, I expect him to clap. Like, hey man, give yourself a round of applause. What's up? So he clapped.
Lovely vibes in knit, just keeping it lit.
He's keeping it lit. He gave himself a round of applause because we detected that word within the input that I gave. And now, if we're able to get the brain to say the word mate, then I'm sure he will point at the screen. So I'm going to give that a try. This might go poorly. What are you doing later? Can we hang out, mate?
Got a sick plans, fam, maybe later. GVI at some thought. Yeah.
Okay, he'll give it some thought. That's a shame. Hey man, can you just say the word mate?
Mate.
There you go. So, it feels more natural when it's included in a conversation. So that's like our little itty bitty smart avatar with his two little behaviors. You can imagine that if you start introducing like dozens or scores or hundreds of behaviors, you can get like a really lifelike looking character that will start to evolve. Oh, and I did want to mention the lip sync as well. You saw that his mouth moves when he speaks. Um, this is a pretty cool real-time animation thing as well. So if we were to look at, gosh, where does this live? Here on his list of scripts, this little one called ULip Sync. This is another open source third-party thing that we just threw in here from the community. We didn't have to write this at all. Um, so yeah, what this is doing is it's predicting like the mouth shape based on the mouth sound. So if you were to make like an ah or an ooh or an e sound as a human being, you kind of know that your mouth will be like round or it will be like a smaller circle or it will be like a long line depending on the type of sound you're saying. And that's all this script seeks to figure out. This is actually a really big system. And my point here is that like we don't need to dive into or understand this system. We just know how to use the results. And that's a lot of what this sort of game development can be when you're starting out. Like you might not know how something operates, but you know how to use it, and that's okay. Don't be intimidated. Yeah, so like when you have this sort of general understanding, you can get pretty far. And that is called a generalist. And that is a whole career in game development or animation as well. Yeah, so in conclusion, I suppose, we have covered a lot of career options here. We've talked about modeling, lighting, animation, motion capture, machine learning, game development, generalist, and there's so many more career paths that like touch these kinds of things that we just haven't even mentioned. Yeah, there's like producers, accountants, like recruiters, ethics board. There's so much stuff. So if you have an interest in this, like there is definitely an avenue you can take to make this, something you could pursue as a career. But yeah, so I hope that this provides a useful like point of reference for like a passion project or a product or like maybe even a career exploration. But yeah, that is the wisdom I have for you, and I hope you enjoyed our little demo, and we can do some questions now.
Amazing. Thank you so much, Sally. That was such a fun tutorial. I can't wait to dig into all the resources too. As a reminder, we did share Sally's resource link in the chat below. So you can feel free to peruse around those resources and try your hand at making your own smart avatar too. Just a reminder, we do have a Q&A, so feel free to submit any questions. Sally, I have a question for you in the meantime. I'm
Yes.
wondering, so I know these smart avatars can be used for personal use, but are there like kinds of industries that use smart avatars beyond just like video games that you've noticed?
Oh yeah, it's like the new rage. It's kind of like do you remember when you would call a company and then you'd get like a robot instead? And you'd be
Yes.
like, I just want to talk to a person. Like it's kind of the same when you go to like a website and you would talk to like the little chat thing in the corner. Well, now they're all kind of like, oh, I need that to be an avatar. So that's kind of like the most low-hanging fruit basic use of a smart avatar, but I think there's going to be all sorts of really creative applications that people can use. I think it will be like, just a quick tangent. Like, I think it would be so fun. Like if my friends and I, like if we each had our own little smart avatar, like little smart Sally or whatever, if my friends could like interact with that, or we could include that in a group chat, like it would be so funny to just see what it had to say. So yeah, there's all kinds of entertainment value here.
It was super entertaining. I love the personality that you created with your little British avatar.
Thank you.
I love the way he talks. Super unique. We got a question here from Kiara who asked, what are foundations we should learn to start making smart avatars?
Ooh, well, I would learn Unity, or like, play around with it. And the material for this course is that exact project I've been showing you. So you could dig in there, or you could look for tutorials. But I think Game Engine is a really good place to start. And if you do not already have foundation in like Unreal or Unity, I would choose, I mean, I love them both, but Unity tends to have more entry points.
Awesome. And do you also, in order to use Unity, do you have to have like a foundation of coding in order to use it?
It's certainly helpful, but you do not need that. In fact, I think it's a really good way to learn some basic coding. Like I found that more so than like a book or like a tutorial or like a book or a class, like a formal education structure, like when I have a project I want to do, if I get blocked because like, oh, I don't know how to write this code, then I like look it up and I learn that exact thing I need and then I grow from there. And it's a very agile way to like learn a skill. And it's very targeted. And to me, that makes it easier. And the immediate practical use of those skills makes it very motivating.
That's awesome. I have another question for you, Sally. What kind of, I know you come from like a film background, a VFX background, you've worked in all this immersive tech, but would you be able to distill down like the artistic and like the technical skills that have contributed to your personal success in this type of career that you have now?
Oh man, this might be cheesy, but the first thing that comes to mind is like if you care about it, it's gonna be a lot better than if you don't. So like working on these films that are so creative or working on a game where, you're invested in it, you're emotionally like, I want to see this succeed. I want the user to have a great experience. I want the audience to have a great time in the theater. Like it helps you put that extra um, amount of time into the equation and you have a sharper eye for what good looks like because you're more critical because you care. So like I think a personal investment is definitely like a skill you can grow if you're not just already passionate about something out of the gate is like learning where to find the thrill and execute.
I love that. Are there any like technical, like hard skills that you feel like people should, it would be beneficial for people to know?
Yeah, I think for like the kinds of project we looked at today, the best hard skill you can have is learning a bit of C sharp, like learning how to code a bit, learning like what is a function, what is a class, like what is an argument, like when do I use a float, when do I use an int, like these kinds of things are very great hard skills in this space.
Great. And how did you learn those skills? Did you kind of learn them on the job? Did you study them in school?
Yeah, I studied computer science in school, meaning like I learned how to program a couple specific languages. But when I got into the job market, none of the languages I had studied was like what I needed. So I had to apply that foundation to like pick up these things either on the job or like in the weeks leading up to the interview. But yeah,
Very cool. All right. Well, I know. Oh, Kiara says, thank you for answering my question.
yay.
Great answer. I do want to do just like a last call for any questions if our audience has. But in the meantime, I did want to share that our next speaker series, if you like this one, will be specifically around content creation. And that will be on May 5th, closing out this school year of speaker series content. Can't believe we've already come to a close with or that we're coming to a close with our school year. And also a reminder that this talk will be recorded and put up on our YouTube channel. So if you check out youtube.com/@BRICFound, that's where you can find this recording and all of our great speaker series content, as well as recordings from our most recent summit. Um, I don't believe we've gotten any new questions, Sally, but do you want to let folks know where to find you if they want to connect with you, or any last parting advice?
Oh gosh. Yeah, I'm on LinkedIn. I'll try to be better with my inbox. I have an avatar like science account. Well, I mean, it's like where I post avatar experiments on Instagram. It's at sallydanger.biz. Otherwise, I've let all my socials lapse, so sorry, world.
It happens. All right, Sally. Well, thank you so much for joining us in our speaker series today. And can't wait to dive into your project files. And folks, if you create your own smart avatars, would love to hear about it. Tell us about it in our comments when this recording goes up on our YouTube, or shout out to us on Instagram. Would love to hear about it. All right. Thanks, everybody.
Bye.
Bye, all.